Welcome to the week 11 concept summary video of Python. Let us start this week with writing a small bit of code, which is, let's say, I want to define a variable a as 5 by 0, and I want to print it. And I also want to define another variable b, which is, let's say, 50 by 5, and I want to print b also. Okay, let us try to run this code and see what it gives us. Okay, so it gave us an error, which is a zero division error, and uh, uh, and we got this because we can't divide any number by zero. So and because of this, the execution of these two lines also didn't happen. So these two lines didn't get executed. So now, is there any way to fix this so that even if this throws an error, this will run? Let's just think of that way. Okay, so there is actually a way to do this, which is by writing a block which is called try except block. Okay, let us see what that is. For now, I want to keep these two lines in a block called try, and then I'll write uh, except, what is that we got here? Zero division error. I'll, I'll just copy this and paste here. So if you get this error, print uh, can't divide by 0. Okay. Now let us try running this. Okay. So first of all, it didn't stop the execution of our code. And the second thing, we didn't get any error. So, see, this two lines, we can clearly see that these two lines got executed because we got the output as 10, which is 50 by 5. So, now let us see what happened here. So, I know that this line has some issues, like it may throw an error. So as we saw, it definitely throws an error because we can't divide any number by 0. So so that kind of dangerous code which is there, I want to keep that dangerous code in a block called try. And I'm basically telling it to try executing this code, and if there is any problem in this, do this instead, right? So first of all, try running this code, and if you face any issue with that code, or if there is any error that came, then if the error that came is this, then you do this thing, which is print can't divide by 0. So what this basically does is, it doesn't throw any error, but handles that error by replacing that error with some line that we write here. Okay, so even if like, even though it is mentioned as zero division error, we call these kind of mistakes as exceptions. So there is quite difference between an error and an exception, which is like, errors are like failures that may or may not be recoverable, and like the errors are basically some bugs or system failures or some logic mistakes that we do in our code. But exceptions are a kind of structured and handleable disruptions that we get in the program that we write. Means we can handle exceptions in some way, right? Like how we did it here. Like we got a zero division error, which is an exception, and we handled this exception with by writing this line, which basically tells the user that you can't divide any number by zero, instead of just throwing that exception to the user. Right. So that way we are successfully able to avoid that exception, and we were able to print a message by saying that you can't divide the number by zero, and then it also didn't disturb the flow of the code which is below that dangerous code. Okay. So this is basically what we call as wait, let me write it here. Exception handling. Okay. So now, let me show it with one more example. Okay. Let's say I want to take an input called age. Uh, I want to print the message, enter your age, and then I want to take the input of it, and then print your age is the age. Right. Okay. I'll run this code and I'll write some value. Let's say I'll write 20. And it prints 20. Okay, what if I enter something which is not a number? Let's say I'll enter my name here. What will it do? It throws me an exception which is value error. So invalid literal for int with base 10. It is so it is basically telling that what you have entered is not an integer. So that's what it is telling. So I want to handle this exception. So how to handle this? Uh, I'll just keep these two lines of code in a try block, and I'll write an exception line except. What is the exception that we got here? Value error, right? So I'll say if you get value error, then print, hey, that's not a number, right? So now let's rerun it, and it is asking for my age. I'll enter, and it is printing 20. And then if I enter my name, let's say, it is instead of throwing that exception to us, it is just handling it by printing this line, which is, hey, that's not a number. Right. So in this way, we have seen two examples where we got exceptions, but we handled them through uh, printing some line instead of just throwing that exception to the user. Okay. So in this way, we can keep whatever code that we think generates an exception in try block, and then we can handle that potential possible exception here by writing something to execute if that exception occurs, right? So this is how we handle the exceptions in Python. Okay, now this is what it is about the exception handling, and then coming to some Python inbuilt functions. Like we have many inbuilt functions in Python. Now we are going to discuss some of them, some inbuilt Python functions which come very handy and help us do some things very efficiently. So let us try looking at a few examples, a few functions. Let us start by a function which is called iter. Okay, iter is a kind of function that we see in Python. So let us see an example where this comes to use for us. Let's say we have a list called fruits with, let's say, apple, banana, and cherry, let's say. Okay, so we have a list with three fruits in it, and I want to create an iterator basically. What is an iterator? Let's come to this in a minute. I want to create an iterator for fruits. So I mention iter for fruits. Sorry, fruits. And then I will, what I'll do is I'll print next of it. Okay, let's run this and see what it prints. Okay, so it is printing apple, and if we see what we wrote in the code, we just defined fruits list with 3 fruits in it, and we have created a variable called it, which is basically an iterator for fruits. So it is basically a thing which iterates through all the elements of the fruits, right? So we want to print all the elements of fruits one after the other by iterating through it. So the first element that we got is apple, and if I copy this line and paste the same thing in another line, and also paste the thing in the next line also, uh, it basically iterates through all the elements and gives me the next element in that iterator. So this next of it basically defines the next element which is there in the iterator. Okay, so there are only 3 elements. So what if I try to uh, write it once more? See, it is basically throwing an exception, which is stop iteration. Okay, so which is basically saying that there are no more elements in the iterator to, like, it's basically saying that there is no next element. That's all. Okay, so if you want to do, you can handle this exception also. Okay, so this is what it is about iter. This comes very handy in iterating through all the elements from in any iterable collection. Okay. So the next function that we are going to discuss is called yield. Okay. What is this yield? So we are going to discuss all of these inbuilt functions with some examples where they come to use. Okay. So let's say I'll define a function called number generator. Number generator, and this doesn't take any parameters. And what it does is for I in range, let's say 1 to 4. Okay. Uh, Instead of printing I'll do something called yield I. Okay. I did something called yield I, and I'll call this function uh, generator generator, and then I'll write print next of j. Okay, let's run this and see what it is doing. Okay, so this is printing 1 here. So what it is actually doing is, as we defined a function and called that function and stored the value of that function in gen, right? And we are printing next of gen. So it, what this is doing is, it basically after the value of I becomes 1, like when the value of I becomes 1, it is returning the value of 1 to this gen, and it is pausing the execution of the that function there. Okay, so it is basically pausing the execution of the function after returning 1 to this gen, which we printed here. So if I do the same thing by copying this line and pasting it in the other line, what it is doing is, it is giving 1 and pausing the execution, and when it sees the next element that we need, then it goes back to the function and executes and returns 2, and then that 2 is printed here. So It basically pauses the execution of the function till where we need. Okay, so here I've explicitly mentioned that I needed only two elements of this gen. So that's why it ran that function only two times. So if I say I need the value of the next value of this gen one more time, then it executes up to three elements, right? So it remembers where it stopped the last time and it continues it pauses where uh, sorry, it remembers where it paused and resumes the execution from there. Okay. Now this yield is done, and then okay. Let us try to see something called list comprehension. For that, let me take another list called fruits and let me add some fruits to it. I'll add mango, apple, banana, orange, and apple, kiwi. Okay. So I've added some, how many? Six fruits in this fruits list. And now what I want to do is I basically want to create a new list as an empty list. And for fruit in fruits, so I'm basically iterating through each element in the fruit. And for that, what I want to do is for every fruit, I want to check whether there is the letter N in that fruit or not. Okay. If it is there, what I want to do is I want to append that fruit into this new list by capitalizing the first letter of that fruit. Okay, so what I'm doing is first I created an empty list called new list, and I'm iterating through each fruit in this fruits list. And if uh, the letter N is present in that fruit, like let's say, let's take mango. In mango, there is N. And let's take apple. In apple, there is no N. So we are taking out all those fruits which have N in their name, and I'm adding those elements into I'm adding those fruits into this new list by capitalizing the first letter of that fruit, right? So now what I want to do is I want to just print this new list. Let's run this code. Okay, so it basically took only those fruits which have n in them, and it capitalized the first element, first letter in that fruit's name. Okay, so we took four lines to do this thing. So is there any way that we can achieve the same output by using only one line of code? Let's think of it and try to do it. Okay, so what I want to do is first I'll define new list. First I'll comment out these lines and I want to build the new list from scratch now. So the new list is basically a list which has okay, first of all we have to iterate through all the fruits, right? So I'll write for fruit in fruits, and I can continue in the same line by writing the condition also, which is if n in fruit. Okay, so I basically wrote the for loop, and I didn't go to the next line, but I wrote the condition also in the same line by giving a space in between. And then if this condition will be true, what I have to do after this condition becomes true is that, so whatever I have to do, I have to write that process here before the for loop. So what I want to do is I want to capitalize root dot capitalize. Okay. So what this is basically saying is that go through the same thing that which we did here. So now let's run it and see. Uh, Observe here in the output thing whether anything changes or not. See, nothing changed. So we are able to achieve the same output by replacing the 4 lines of code with just one single line by writing all of the loop condition and the process that we have to do after the condition becomes true. All of those we were able to fit in a single line. So our work is done by a single line. So this is a short version called list comprehension. So through list comprehension, we can achieve uh, the things which take many lines of code in a single line. Okay. So coming back to the functions that we were talking about, like this iter, yield, and all. So there is one more function like that called lambda. Okay, what is this lambda? Let's see. Uh, so lambda is basically like a tiny one-line function which doesn't have a specific name to it. Okay, first before going to lambda, let's try to write a simple function which adds two numbers. Okay, let's define add which takes x comma y and it just returns x plus y. See, very basic function which we all understand. And now I want to print uh, add of let's say 5 comma 3. Okay, I'll run it and see it is printing 8, which is 5 plus 3. Okay, can I do the thing that I did in 2 lines in a single line? And that is where lambda comes very handy, which is that I can just define a variable called add and I can just mention lambda x comma y and take this x comma y and produce the output x plus y. Okay, now I'll comment these 2 lines. Now I'll rerun it. See, it gave the same output. Okay, so like to write any function, any lambda function, we define a variable and then write lambda and then mention what are the input that it has to take. And here after we mention a colon and then we mention what the output should be. Like how should it compute the output from the input. Like here we just wanted x plus y, so we mentioned take x and y and uh, generate x plus y. Okay. Now coming on to one more function which is called enumerate. Enumerate. Let's see what this is. Let's write a short code. Let us take fruits only. Uh, Apple, banana, and cherry. Let's say. Okay, so we took 3 fruits, and then I'll write something for index comma fruit in enumerate of fruits. Print index comma fruit. Let's run this. And one more thing, if like you can run any of your code by either clicking on this run button or you can press control enter on your keyboard. That also basically runs the code. Now I'll press control enter, which ran the code and gave us the output 0 apple, 1 banana, 2 cherry. Okay, so what this basically does, what enumerate does is this gives you both the index and the value when looping through the elements. Okay, it's like counting while reading a list. Okay, so what I did is for index and fruit in enumerate of fruits. So loop through all the elements of fruits, and for each element, print the index of it and the actual element. Okay, so that's what it did. And let's go to check one more mm, function, which is called zip function. Okay, let us see how this comes handy. Let us say I have a list of names of people. Let's say John. J. Okay, I have three names, a list containing three names, and their corresponding scores also I have. Let's say 85, 90, 95. Okay, I have two lists, names and scores. Names contain names of three people, and scores contains scores of three scores basically. Okay, now what I want to do is for name and score in zip names scores, uh, I want to print name scored score. Let's print this. See, it is actually mapping each element of this to this. So it is like a zip which first takes one element from this and takes one element from this and then goes to this and then goes to this and the third element of this and so on. So it basically like taking let's say you have two baskets full of balls, and what this zip means is that you are taking for let's say you have two boxes named A and B with balls in them. So first you take one ball from box A and then you take one ball from box B, and then you come to box A again and take one more ball from it and go to B again and take one more ball from it. Like that you zip through both the elements, both the lists, and mix them basically. So this John scored the score of the first element 85, Jane scored 90, and Jack scored 95. Okay, so that is what zip is. And the last function that we are going to discuss today is called map. Okay, so let us see what map is. So map is basically used to apply a function to every item in a list. Let's say we have again fruits only. Uh, Today we are using fruits so much. Okay, same the apple, banana, and cherry. The same example I'm taking. And what I want to do is now let's see whether lambda comes to use for us, because what I want to do now is that I want to uh, turn all of these fruits into their into uppercase basically. So uh, apple should become apple in uppercase, and banana should become banana in uppercase. So that is what my goal is. So for that, what I can do is I can first use lambda function. Uh, so I can lambda is function is basically that we saw here, a short function which takes input and produces output. So in lambda, let's say we take a fruit and produce the uppercase word of that fruit. Okay, okay. So this basically takes the fruit and produces the uppercase version of that fruit word. So now I want to map every element for in fruits. So that's why I mentioned. Okay, so map basically takes two arguments. First one is a function, and the other one is a an iterable. Okay, so what map does is that it applies this function which it took as the first argument to all the elements which are there in the iterable which we gave as the second argument, right? And I want this as a list. Okay, so I'll mention list of this whole thing, and I want to print this list. So I'll write print. See, it may seem confusing that we wrote everything in a single line, but it makes sense if you go on by understanding each individual function differently by following these parentheses. This is the innermost parenthesis, and these are the next parentheses. So if you go from inside to outside, then it will make sense. Okay. Now let us try to run this. Okay. So we have achieved our goal by turning it into capital uppercase. Okay, so these all are the things that need some a bit of practice, because it may seem that you got it when you hear them for the first time, but it basically needs some practice for you to own them. So practice all of these inbuilt functions with different examples also, other than which all I have mentioned. So then you'll be able to do it. Okay, so those are the things that are particularly there in week 11, which are exception handling and these all the built-in functions which we discussed. Okay, so thank you for watching.